Good evening, everybody, and welcome to another episode of vBrownBag. Tonight, we are continuing our IT series, our IT career series, and I'm very excited to have an old friend of the show, Mr. Tim Davis, on. Tonight, he is going to be talking about automating the life cycle of infrastructure as code, from deploy to destroy. Before we get into it, let's go with a couple of the show notes. Get in on the conversation. If you are on Twitter or if you are in the live studio audience, we will be responding to Q&A questions, both in the chat channel and the QA panel. If you are on Twitter, if you @vBrownBag or #vBrownBag, we will be paying attention and we will make sure that all of your good questions get bubbled up to Mr. Tim. and even some of the bad ones. I don't care.
I have a feeling with me being on here, there's going to be some bad ones and some folks who just want to make fun of me in some way. That's cool.
What's your favorite color, Tim? What? So if you want to follow Tim, you can follow him. It's very easy @vtimd. He's got a fun timeline on his Twitter handle. You will learn all you want to know about Audis and baked meats, and it's a cornucopia. You never know what you're going to get. If God forbid you want to follow me, you can follow me @Mistwire. I will be giving you updates on my cats and the vBrownBag schedule. And of course, as always, we have my co-host Ziggy Englert. You can follow her @SIGNEENGLERT. The hardest one of the three. Cool. All right. So with that, Mr. Tim Davis, are you ready to be bestowed the power?
Well, why not? Let's figure this out as we go along.
There you go. We'll do it live.
Excellent.
You have screen sharing powers, I believe.
All right. Yes, I do. I'm pulling that up right here. Let me share. I am going to do this in a half demo, half slide format. I hate slides, but I'm going to set it up a little bit. Then I'm going to jump into a demo. I'm going to use the product that I work for right now, but just the concepts that we're going to talk about translate through to several other products that I'll mention here. So, it's not just going to be a giant commercial, sort of. So, so I'm Tim Davis. I am DevOps advocate with M0. We are a tiny startup. I was employee number 9 of what I think now is 16. And we focus on infrastructure as code automation. That's kind of our bread and butter. Before that, I was at VMware. I was part of a group of people who created the Cloud and Developer Advocacy Program over at VMware. Before that, I was part of the Networking and Security Business Unit as a pre-sales SE for NSX and some other things like that, which is where a lot of the folks in the community here know me from at that point. Before that, I was actually over at Dell. I was an enterprise architect working with Dell Services. That's now, I think, NTT Data or something like that. Dell got rid of it, whatever. And before that, it was at SoftLayer, and I was in infrastructure operations as a data center ops technician. So really, my background is infrastructure. That's where I've been. I've been all the way through systems administration. I worked on the phones, doing support, pretty much everything you can think of in terms of systems and stuff like that. But I'm always focused on the app. There's no point in delivering infrastructure if you're not delivering infrastructure for the sake of running the application that runs the business. Now, in the past, I may have told you otherwise and just said infrastructure is cool, I'm doing that. But really, again, there's no point in that if you don't have some kind of app that you're trying to do. So that's always kind of the key focus of what I was doing. There's an agenda here. I'm going to completely scrap that because I don't care about agendas. Some key terms that are kind of important: static environments versus dynamic environments. Static environments are your classic lab. You have your stack of hardware, you have stuff deployed, you may have your application configured on there, but it doesn't really do much. It doesn't change very often. You may have it set up to where people have to ask who's on dev or who does this, because if somebody introduces a breaking change when somebody else needs it, that can cause problems. I've worked in several shops where the development lab literally had the exact same SLAs as production. It absolutely could not be down for any purpose. And that can be difficult. It's not really a development sandbox or a lab if you have to keep it up just like production. And that's really where dynamic environments come in. So they allow you to, spin up environments. They're real short-lived, ephemeral environments. You use them just as long as you need them for purpose X, Y, or Z. And then you burn it down. You need something else, you do another one. And that's kind of where we come in. We can help with the static environments. What we're going to show you kind of helps with that. But really, if you're utilizing dynamic environments, you're going to get the most out of infrastructure as code and, spinning up and automating everything. I'm sure everybody here has seen some form or version of this slide. I have presented a form or version of this slide in several past jobs, but it kind of makes sense for what we're talking about here. Old school architectures, 3-tier, you have your giant monolithic applications. They don't change very often. And that's one of the reasons why static labs are around, is because the applications were very static. Not a lot happened. Every once in a while, you may upgrade it, reboot it, and you're done. You're back to where you were. But nowadays, with cloud native architectures, with microservice architectures and things like that, there's a lot of moving parts. A lot of things are happening at once. You may be spinning in one thing, changing out another, adding a piece, removing a piece. There's a lot going on there. And that's really where the dynamic environments, the infrastructure as code and stuff like that has really come up and become relevant. Developers are deploying more and more infrastructure these days. All right. Way back when, it used to be called shadow IT, and developers were basically going around infrastructure folks like myself, swiping a credit card and, building up whatever they wanted. Nobody cared about security. Nobody cared about anything. They didn't care about budget. They were just trying to do it faster. I worked for VMware, whose sole purpose was to try to give you public cloud level agility on-prem, and you absolutely can if you go that route. But still, to this day, going to public cloud, swiping that credit card and building up an instance in 30 seconds is by far one of the fastest ways. And the reason developers keep doing this is just because it works and it's fast. They're able to do what they need, get rid of it, and move on, as opposed to asking who's on dev or, going through and figuring out if they can use the lab, if they can reboot the lab or what have you. And that's really what pushed us towards infrastructure as code. If you're not familiar with that, it's exactly as it says. It's infrastructure as code. Rather than jumping into a UI of a cloud provider or a cloud management platform, clicking around and saying, I need an instance, it needs to have this, it needs to have this, you're literally writing a file that says, I need it to, in the end, look like this. You run it and it goes out and it spins up whatever you need, configures it, and you're done. It's really kind of the developer's way of solving an infrastructure problem, because developers speak code. So they want to build infrastructure and write it in the way that they know it. Now, of course, there are some, different languages they need to learn or anything like that, but there are ways around that. There are lots of different infrastructure as code choices out there. You can choose cloud specific if you want to do ARM templates or in Azure, or if you want to do CloudFormation in AWS. But a lot of folks are moving towards the Terraform route. Terraform is an cloud agnostic, infrastructure agnostic platform where you have tons of different providers that do tons of different, not only cloud providers, but also different SaaS stacks and even some hardware. I believe they have some F5 providers and stuff like that that will help you automate physical hardware. There's also TerraGrunt. That's kind of a fancy wrapper on top of that that helps you do it a little differently. And then there's Pulumi. Pulumi is getting more and more and more traction these days, simply because you don't have to learn a new language like HCL with Terraform. You utilize the code frameworks that you're already using. If you're writing your application in Go, why not use Go to write your infrastructure as code? So that's really where Pulumi is coming through and kind of jumping onto the scene quickly. Moving to infrastructure as code, if you have an application out there, before you start automating it from deploy to destroy, there's several different things you need to think of. Are you going to start fresh? Just taking the application you have, maybe finding a new version that allows you to kind of templatize it a little better. Or are you going to take the exact infrastructure that you've already got and turn it into infrastructure as code, kind of working backwards? Terraformer is a Google tool that you can actually point at GCP and I believe AWS as well to a degree. And it will go out and you point it at your application and it will then write the infrastructure as code files for what's already there, as opposed to starting fresh, writing the infrastructure as code, spinning up the new infrastructure and then going that way. It kind of takes what you have and writes backwards. So there are different options for how you need to do that, but that is a critical step of selecting which infrastructure as code framework you're going to use, how you're going to move to that. Once you do that, it kind of allows for a little bit more agile development. You can develop on your local machine. You can create a PR, do end-to-end testing on a dedicated infrastructure. So you're not having to go in and just test whenever you can in the lab. You have an entire instance of that application that you can then go test against. And then when you're ready, you can go back through, merge to main, that'll get deployed out to production, and you're all set. Why dynamic environments? It pretty much speaks for itself, not having to coordinate who's on there, who's going to implement a breaking change, who can do what. It really makes things go a lot faster. There's a lot less wasted resources. Now, you would think you have one stack versus having 50 different stacks, but the difference with that is with your short-lived ephemeral dynamic environments, those are getting burned down as soon as you're done with it. You could have one that's only being used for 4 hours, one that's being used for a day, one that's being used for a week. As soon as it's done, it's going to get burned down. You're not paying for it anymore. So it really helps you kind of cut down on that so you're not spinning out a bunch of stuff and leaving it out there. Now, how do you do this? The very first thing, everything we talked about, you have to templatize your infrastructure. You can't go through and start spinning it out and creating a repeatable manner unless you have it set in infrastructure as code or some way that you can quickly spin it out. Figuring out your strategy. Are you going to do it per pull request environments? Are you going to do per developer environments? Are you going to set maximum time to lives for how long it's going to be there? And that's where it comes in with the implementing the deploy and destroy automation. And that's really where we come in, as well as some of our other counterparts here. There's so many different ways that you can actually come through here. CI/CD is a big one. Lots of companies are already doing this with, Jenkins or Circle or a few others. But those are really programmatically focused on release management and pushing applications out there, and then they kind of wipe their hands of it. There's a guy in the DevOps community named Eric Osterman that runs the Sweet Ops office hours once a week, which is a really good web series. He has people on there talking about DevOps. There's also a really good Slack channel involved with that. And he coined a term called tacos, which is what we fit into. And it's kind of a new niche, and it's Terraform collaboration and automation software, or Terraform automation and collaboration software. Sorry, backwards. And it's really that kind of niche that we and Scalar, Terraform Cloud, and Spacelift all kind of fit into. And we are focusing on the infrastructure as code lifecycle. So as opposed to CI/CD, that's very transactional, it'll kick it out the door, wash its hands of it, and be done with it. We're really going to focus on not only the deployment, but if you need to do continuous deployment for redeployments, for updates, if you need to do pull request plans to figure out what's happening, if you do a pull request, what infrastructure changes are going to happen, going through and figuring out role-based access control for who can deploy this and when and where. Those are things that you're not really going to get if you use just a regular CI/CD pipelining tool. So that's kind of where we come in. I'm going to jump over to a demo here and kind of show you how we can set that up. A lot of the concepts that I'm showing you here can work across any of our competitors or anything. I think there are a lot of things that we do better. I may be biased, but who knows? We'll figure that out someday. But it's just one of those things where using a specialized tool that is purpose-built for automating the life cycle of deployments, it's going to help you do what you're doing a lot more efficiently. It's going to help you keep the controls on there. And it's going to, at the end of the day, make what we're talking about here a lot easier. I'm going to skip that here because we don't need that just yet. All right. So this is our platform. This is M0. We are a taco, for Terraform or really any infrastructure as code. I put a nice little hat tip here to Chris because when I signed up for this, I did not realize that it was going to be St. Patrick's Day. So cheers to everybody here. Lovely. All right. So we actually have a 3-tiered kind of hierarchy for how this is set up. We have it set with an organization as your top level. Then it goes down into projects, and then underneath those projects are going to be the deployments. Generally, the way we see that is under projects, you'll have like your dev, and then you'll have your production, and then you may have your ephemeral or research environments or what have you. But really, you can set that up in whatever way makes the most sense for you. You're going to need a place for your variables. So when you're doing infrastructure as code, you don't necessarily want to go through and hard code all of those values in and have a completely separate set. That's definitely a big pitfall when it comes to people writing and utilizing infrastructure as code, is having to have multiple copies of the same code for the same app. There's a programming methodology or, what have you out there called dry or don't repeat yourself. And it's trying to create repeatable code that you can utilize over and over and over. And when it comes to infrastructure as code, that means writing where you've got variables open so that you can have a more generic set of code that you can utilize across production and across development and across your research environments, but then inject in the variables that you need for any specific tasks. So with that, we purposely scope our variables at 4 different levels. We do it at the organization, at the project, at the template, and also at the environment level, so that you don't have to copy and paste those over and over and over again. If you're using the same cloud credentials throughout the entire organization, great, put it there. If you have a different cloud account for dev versus production, put those there. Long story short, it's much better for you and the way that you work if you kind of generically set up everything and then utilize those variables as you're going through. For us, we don't go off the workspace construct that Terraform does. We go off of templates. Templates are where we actually set up our set up our infrastructure as code. We pointed at the repository. For the basis of our example here, I'm using the HashiCorp Terraform AWS provider 2-tier app example. I've also dumped in a couple of extra files and made some changes here, such as some open policy agent that I can talk about if we have enough time at the end. But really, this is where we're going through and setting up what we want to deploy. And with this, we have it set up in such a way that we can use the same code base for development, for production, for all of these other things, depending on what cloud accounts we inject, which variables we set, what names we use. That allows us to kind of use that same file over and over and over again. If you are going to be having a really quick development cycle, you've got a bunch of developers, or you personally are spinning up a lot of environments quickly, you don't want to have to keep going and editing that code over and over and over again every time you redeploy it, or have 16 different repositories that have the same code with different hard-coded values in it. I can't stress that enough. Making sure it's general and then using those variables in whatever you do, that will make your life easier overall. So let's go into the project here. I have my vBrownBag project. I've got one of these already spun up. I'm going to go through and destroy that here. Hopefully my AWS keys for this session token hasn't timed out yet, but we're going to figure that out the hard way, probably. All right.
Quick question while we're waiting for that.
Yes, absolutely.
Where are you storing your secrets? Are they local, or are you keeping them in the TF-vars file?
That's a great question that I wish you didn't have to ask me. So we are taking those secrets, and all of my secrets are stored in our app. We have 2 different models for us. We have a full SaaS version that stores your secrets with us. We have our SOC 2 Type 2 if you want that. We also have a self-hosted agent model, which keeps the secrets in AWS Secret Manager. I know some of our other competitors, they have full on-prem stack for like Terraform Enterprise. Scalar also has a fully deployable stack on-prem. So for us personally, it's either with us for SaaS or with you for self-hosted agent. But really, a lot of folks are using Vault if they're using Terraform Cloud. I see a lot of Vault around. It isn't the cheapest solution on the planet. Right. We personally currently don't offer any other third-party integration for that. You'll see that change down the road. But yeah.
Cool. Okay. Thank you.
You got it. Now let's find out what happened with my environment here. Destroying progress. Oh, good. My keys haven't expired. Dynamite. All right. I wanted to clear that out because I want to show you from, the way that we set this up, and it's kind of the same across others. So we've gone through and we've set up a template. We created our template. I guess I can go back and do it that way. So we created our template. I selected Terraform. We also support TerraGrunt by default, but then again, we can also use our custom flows agent, which I'll show you in a little while if we have time. We can support any infrastructure as code framework. We have the ability to essentially script in any type of third-party tool chain we want at any point in the deployment we want. I set the template name for SSH keys. If we were connecting to a private repository, or if we were running Ansible or something like that after the fact, we would need an SSH key to go through and either connect to the repository or the instance. Retry on failure is something that if you're automating the lifecycle of your infrastructure's code is very important. The biggest example I have is if you're deploying EKS with Terraform, it absolutely will take forever. It is a giant pain that takes like 20 or 30 minutes to spin up an EKS cluster. And Terraform absolutely will time out on you every time whenever you're running that. So if you do retry on failure, it'll go through, Terraform will time out, Terraform will fail, and we can just go through and kick it in and say, hey, go through and automatically do that. You can also do that with the CLI, but we kind of make it a little easier when you're setting up that template. So if you know that it's going to fail every time, you can just come through and say, on deploy or on destroy or both, automatically go through and retry so that it just keeps doing it until it comes up or it goes down. So that's something to think about when you are automating that life cycle. Is for big things, it will time out. Terraform's default timeouts are pretty low when it comes to giant, clunky things like EKS. Next thing we're going to do is we're going to connect it to a source code repository. I mean, the whole point of infrastructure as code is you are coding, you are programming. Those files are generally in a source code repository. A lot of people like to think, oh, I have Terraform and I have it in Git. I'm doing GitOps. No, you're not. That's something that has made me kind of like twinge a little bit for a while. GitOps is something extremely specific. That term was coined by a company called Weaveworks who created it. And GitOps, by definition, is infrastructure updates by pull request. So if you are not updating your servers, adding nodes to the pool or what have you by doing a pull request in Git, checking everything, testing everything from end to end, and then merging it back to main before you go and deploy that to production, you're not doing GitOps. Just putting Terraform in Git is not that. That is one of my many hills to die on. So I'll just point that out there. So we're going to use GitHub. We have a deep integration with GitHub or GitLab. We can also utilize absolutely any other source control you used. We just need the URL and a Git token to access that. We'll select what repository we want, what branch we want. This is important. If you are utilizing and you have made your source code generic, you want to be able to create different deployments off of different branches. Obviously, your main or your master branch is going to be your production. But if you have pull requests and you're doing per pull request environments, you want to be able to change that branch so that you're spinning up off of your feature branch and not trying to do a pull request with the code in main because that hasn't been merged back yet. And then for us specifically, since we don't utilize the workspace construct, we can use it, but we don't focus on that. We look for the Terraform folder. And one of the reasons we do that is because when it comes down to infrastructure as code, you have several different options when it comes to designing how you're going to do your repositories. You can do multi-repository, where if you have different modules or submodules, those are all inside of their own repo at the root. Or you can do what's called mono repo, where you've got a bunch of different subfolders in there that have all of your different modules, but it's one main repository. So for us, we really want to be able to focus on a specific module. And if you have a mono or a multi-repo, great. You just point us at the root of that and just go like that, and it'll be fine. You point us exactly where those infrastructure as code files are. But if you do have a mono repo or you have it in a subfolder, we want to know exactly where those files are so we can come through and look at that. I did mention that we kind of scope our variables down. That way you don't have to repeat yourself. If you see here, we have one variable that's set up for instance type. I've got this set up in such a way where we can either select micro or medium, and I'll do 2x large for later in case we get there. Cool. And I will save that. It's also got our organization level ones that we've already got set in there. And then for us, we select what project. So because you don't want to have to create a bunch of different templates for dev and for staging and for all that, we allow you to go through and then select and assign that one template to all of the different projects that you have that make that work. So let's go deploy that. So we're going to create a new environment. We're going to run now. We're going to say what environment we want. We'll say what revision we want. So which, flag we're there. Redeploy on push to the Git branch. If you want to do continuous deployment, you're going to need some kind of webhook back and forth between whatever platform you're automating with, so that whenever there's a push to that branch or that repository, it's going to go through and it's going to redeploy. Now, because we have, the ability to go through and use big mono repos that have a bunch of different subfolders, you don't want to rebuild the entire repository's deployments if you just edit one little submodule. So we have the ability to actually focus that and only do a continuous deployment on that deployment based on that submodules folder. Now for this, we're also, TTL is important for that. If you want to keep it up forever for static environments, great, absolutely do that. If you want it to only be around for a week or for a month, a key use case we have for this is we've got a company that has a software that they're developing, and their pre-sales SEs utilize ephemeral demo environments. So they will spin up an environment, they will do their customer demo, and then they will burn it down. Well, half the time, nobody's going to remember to do that. If you go through and you set a specific TTL for that, then after 12 hours, it's just going to automatically delete itself. That helps you really clean up those environments and keep it down. Most of the Taco platforms will allow you to do that kind of TTL, or you can script it in some way. Specific environment variables, if you want to go through and inject at that time of deployment, you can always do that. And then we have the either approve plan automatically button or not. If you're doing a developer self-service environment and you want to give them the ability to spin stuff up in dev all day long, great. Do that, approve plan automatically. But say for production, you don't necessarily want to do that. You want somebody else, like the two-man rule, you want somebody else to look at the plan before it's actually approved and pushed to deployment. So you can uncheck that, at which point it's going to stop. I don't want to do that right now. So I'm going to go ahead and hit this, and it's going to start our deployment. And yet again, I'm going to cross my fingers and hope my session token hasn't timed out.
I think I speak for everybody when I say that if your tacos aren't gone in 12 hours, you're doing it wrong.
Oh, I'm telling you, that's for sure.
Every time you say taco, I immediately think of Ned, by the way. I just want to throw that out there.
Oh, really? Nice. I love it.
He in his Pluralsight Terraform classes, everything is taco oriented. Everything. Like he is.
Oh, I love that. I haven't actually seen it.
Oh, they're really good. He's got some really good Terraform stuff on Pluralsight, but it's all tacos.
Awesome.
Tacos all.
I am going to have to look that up. As soon as we were invited to the Sweet Ops office hours where he coined the term tacos, I was so excited. I mean, I'm from Texas. Tacos is a food group. I love it. And the fact that somebody took the tiny little niche of the industry that I'm working in and named it a taco, it couldn't have worked out better, I think.
it's kismet. It was meant to be.
Absolutely.
That podcast was Sweet Ops office hours.
Yes. So Eric Osterman is Sweet Ops basically, and he does a DevOps office hours. I can send the link over if you want to put it in the show notes or something.
I got it. But somebody was asking about it, so I just
awesome. Yeah, it's a really cool Zoom meetup once a week, and sometimes they'll have people in there to specifically present. Sometimes it'll just be open conversation. There's also a really, really cool Slack channel involved. There is some extremely smart Terraform folks in there in the Terraform channel.
Nice.
I highly recommend joining that Slack channel and checking it out if you need help or if you're doing infrastructure as code or really anything DevOps. He's great for that. All right, looks like we're done. Our deployment processes look pretty much just like any other CI/CD type pipeline. We're going to clone down the information. We're going to get the Terraform state. So if there is already a deployment, we'll go ahead and check that state. We have the ability, if something's already deployed and you want us to essentially inherit, we can utilize the workspace. By default, we'll just generate our own. But if you put the workspace name in there and point us at whatever cloud account it's at, we'll go through, we'll see that it's already there. We'll check against the state. Sorry. And then we'll then own it from then on. That's where we're going to load after that, our M0 YAML file. So this is really our secret sauce. This is where I think we excel and really bring a lot of extra value. We have the ability to script in at any point in the deployment bash commands to do whatever. If you want to put it, say, before the Terraform init or after the Terraform plan or after the Terraform output, you just start scripting in your bash commands. Our container by default has a bunch of stuff, Python, pip, all of the cloud CLIs, kubectl, and everything in there. So we don't want you just to deploy the infrastructure. If you want to run Ansible to install your application and configure it afterwards, if you want to run kubectl to then apply all of the manifest YAMLs, you can do that. If you want to utilize some kind of piece of software that's not on this list, you can just pip install it into the container, or bash or curl and then do a bash install. Big use case that we have for this that I recently wrote up is a customer wanted to utilize Chekhov from Bridgecrew, which is a CLI tool that parses your infrastructure as code files and checks for misconfigurations, like S3 buckets that are open to the public and stuff like that. We can actually code that in so that it will go through and it will check all of your infrastructure's code files after the Terraform plan, but before the Terraform reply, so that if there is a misconfiguration that you wouldn't want deployed to production, we can stop that from happening. That's actually the same methodology that we use to implement Open Policy Agent as well, which is policy as code that goes with your infrastructure as code. We have some policies baked into the UI, like the time to live, as well as maximum number of environments per user, and the default behavior of the apply automatically button. But really, if you want to utilize OPA or Open Policy Agent, you can go through and set policy for whatever you want. For example, in my repository here for this application we're using, I have tflib.rego, which is essentially a file that allows it to read my Terraform libraries and go through and parse the thing. Rego is the Open Policy Agent language, which I don't know. I don't understand. I got somebody else to do this for me. But good luck if you want to use that. And then I have the validation.rego file. This is actually the check that we're doing. And the check that I'm enforcing is checking for allowed instance types. So it's only allowed to deploy either a T2 medium or a T2 micro. When I was going through earlier and we were talking about the template, I actually went through and added a different variable value in there for a T2 2 extra large. If we notice, we loaded this, it's going through, it's running. We did after Terraform plan is when we did that check. So we'll come through, we load the variable values, we're going to set the Terraform version. We specifically will support absolutely any Terraform version. By default, we are running version 0.12.24. If you want to pin any version you want inside of your Terraform code, we will automatically utilize that. If you want to use an environment variable inside of our product to tell us what version, great. We had the distinct ability to say we supported 0.14 on release day because we don't care. As long as we can go out, pull that provider down, we're good to go. So we support absolutely any version you want to use. We're also going to do tagging resources. So this is another cool thing that we're going to do. And obviously I don't have that installed on this, but we have a module that we created called TerraTag. That is open source. So anybody that's utilizing Terraform today in either AWS, Azure, or GCP, you can go to M0's GitHub page. You can get TerraTag and use it for free. It's going to go through and recursively check all of your infrastructure's code files for taggable resources. And that's important because not all resources are taggable. So we'll go through, tags the one that does, and that kind of allows us to actually do cost over time versus deployment. So we can go through and check the logs and say that our cost went up, by $3 a day, go back through and check the logs, see the Terraform plan, and see exactly what happened. So that's something really cool that we do. I know a lot of cloud management platforms these days utilize tags to group things, to be able to do reports and stuff like that. So we've released the ability to do tagging for whatever you want for free, or it's built into our product to help you tag and do cost monitoring. We're going to run the Terraform plan. We're going to run after the Terraform plan. This is where it's going to run our OPA. Since we have it set to a T2 micro, that's actually going to work. And then we've got our Terraform apply. It went through and does its own thing. Terraform output, store, Terraform state. We personally are not a Terraform remote state backend. If you do not set a backend in the code, we will create an S3 bucket. It will be encrypted. We will drop the state file in there and be done with it. Best practice, use a remote state backend, even if at very little, your own S3 bucket or whatever in your own, cloud storage, do that. Otherwise, we'll just drop it in an encrypted bucket and be done with it. Let's go through and see what happens when we want to change the instance type. So let's go and redeploy. Let's go to our variables here. Let's try that T2 extra large that I was talking about and see what happens with our OPA enforcement. We're going to improve automatically so we don't have to wait. And while that's doing that, let me stop share. Let me start share. Where is it? Slack. All right. So with all of this, nobody really wants to sit there and look at the UI. When you're automating, having webhooks into Slack or Teams can be important. With us, we have the ability to go through and shoot notifications out for exactly what's happening. Obviously, when I was setting up this environment from scratch an hour before we started, I had problems with that, forgetting that I needed to put certain variables in, and I used main instead of master on that, but whatever. If you're doing workflows, nobody wants to look at it. Nobody wants to wait. If you have those notifications, you can very quickly see what's being deployed, who's doing it. If I were to click this link, it just brings us straight up into the environment. If you are waiting for approval, you can click that link. It'll take you right to the page where you're waiting for approval.
If you're sharing, no, okay, never mind.
Yep, sorry, I had to switch. Rather than share my whole desktop, I was jumping back and forth. So we have our deployment. We changed to that T2 extra large, and it failed. So if we come through here, we saw that OPA failed, instance type not allowed. So we've already stopped ourselves from deploying something that we don't want. This is important because when you enable self-service development, when you enable dynamic environments, it gives people the ability to go up and spin up whatever they want. Keeping the guardrails on there of who can deploy what, how many they can deploy, that's something important. You don't want your cloud bill to be overrun. You don't want to end up having to, talk to Corey Quinn and figure out how to get that changed. So it's just one of those things where being able to give people the freedom to deploy whatever they want, whenever they want, while still keeping it within reason is something that's super important, no matter what tool you choose, no matter what methodology, what framework. You want to make sure that it stays consistent, repeatable, and also secure and within your boundaries. So we've gone ahead and done that. We'll redeploy one more time. We'll go back to micro. Also, destroy environment. Destroy environment after, I don't want to do 12 hours. What time is it? 8:10. Yeah, let's do 8:30. Well, let me do. Oops.
At least 1 hour from now.
Oh, did it say that? I wasn't paying attention.
Upper right-hand corner.
Dang it. I've never tried to do that specifically before. Sure is.
We'll do it
I've
live.
never tried to do something with, I've never tried to do it within a specific time frame that quickly before. So I'm going to try to get that fixed because I don't like that. So either way, this is one thing to help you with that destroy environment. Setting a time for how long it's supposed to be up is something that can be important. Or making sure that you are actually scheduling that and going through. Speaking of scheduling, as soon as this is deployed, or I guess I can do that now. So we have our continuous deployment triggers. Going through and doing plan on pull requests. So if you are doing an actual GitOps methodology, when you do a pull request, you want to know what it's going to do. You don't just want to merge that back to main if it's going to, somebody fat fingered it and is spinning up 100 instances instead of one, or, if they're adding 50 nodes to the Kubernetes cluster. So being able to see that plan on pull request, what we'll do is we'll actually go through and put the comment inside of the pull request in GitHub, and it'll give you, this is how many are getting changed. This is how many is getting added. Here's a link if you want to see the whole plan, but it's also doing service checks. So if you have OPA, or if you're doing checkoff or something like that in the deployment, and one of those fails, it's actually going to send a failed service check to GitHub. So it will not actually let you merge back to main. So that's something that really helps out with that automation from end to end, is having that integration into your service provider for doing plans, doing checks, and things like that. Workflow triggers is something where if you are automating everything, if you do submodules, You can use TerraGrunt, which by default has kind of a cascading effect with how you set up those modules and repositories. But we have the ability to manually do that with Terraform by setting up a workflow trigger. So if you have a mono repo and you have a bunch of submodules, if after module A is deployed, you want to deploy module B, C, and D, then you can actually set up that trigger as subform. So you can say every time module A is deployed successfully, I then want to deploy B, C, and D because they are, interdependent. So we have the ability to kind of mimic the cascading install effect of TerraGrunt without actually having to refactor all your code into TerraGrunt. Scheduling is also something that's big. I can't for the life of me remember the name of the product, but when I was working at VMware and Cloud Services and we acquired Cloud Health, we were working on a use case of scheduling environments. So people wanted to set up their dev so that it shut down at the end of the day and then it spun back up in the morning and it wasn't up on the weekends. That if you really have that automation set up, that's the one. Perfect. Thank you so much. I had a meeting earlier today where I could have used you to answer that question for me. We have the ability to kind of mimic what they're doing, and we can actually set up cron expressions for deploy and destroy schedules so that you can burn down the environment at the end of the day and spin it back up right before everybody starts in the morning, at which point in time you're really going through. It's extremely dynamic, and it's allowing them to save that cost and not burn those resources that nobody's using in the middle of the night or on weekends. So that's something that we do well. I know a few of our friends in the industry do that as well. So when you are working on automating that life cycle, if you do want to save and only do it during specific times, finding out how you can make that tool work for you to schedule is something that is definitely important to kind of look at. Looks like we've gone through and we are back active again. Because obviously I do not understand my own product and timelines, and I couldn't set a TTL to expire on me in 5 minutes. We'll simulate that. So let's pretend that I got a nice little note in my Slack channel that said it's about to go away. We'll go ahead and destroy that manually. We can approve plan automatically. If you need to check out new code, you can do that. I don't need to do that. And then we'll go ahead and destroy. That destroy can be done several different ways. You could, expire by TTL. You could have the, scheduling set up where it's going to destroy that at the end of the day, spin it back up again. That really kind of completes that lifecycle management from deploy to destroy. When you're doing infrastructure as code, you're trying to do dynamic environments. That second part is kind of overlooked. A lot of people will go out and spin stuff up with Terraform all day long. Everything's great. They don't really think about destroying it in the end. So really making sure that you have that tool that's helping you to, control that entire life cycle is something that can really help you out along the way. And looks like we're going through. We're doing our destroy. That should be pretty quick there. But really, that's it. It looks like we have about 15 minutes left. Hopefully that wasn't too much of a commercial. Like I said, a lot of the stuff that you can do in our product, you can do in other products. I think ours is the best, obviously. We do it better than anybody, and I think that's true. But it's definitely something to look at if you weren't familiar with tacos before, other than the food. It's definitely a new niche. We do not have a Gartner Magic Quadrant. I just talked to Forrester yesterday, actually. So hopefully they will be, taking notice. They will be creating, our little nook of the universe there. If you're doing infrastructure as code, you're trying to do dynamic environments, you're trying to kind of speed things up and be a little more agile. The group of us that are doing that specific automation can definitely help out.
Nice. Quick question. It sounds like the OPA section of your technology and certain other things like control tower SCPs have a little bit of overlap. Is there a way that if somebody has a pre-configured control tower with SCPs, can they leverage your technology and take the rules from the SCP, or is that double overing it?
So you can utilize anything that accepts either CLI or API requests, and that you can utilize our custom flows. So where I mentioned you put code like, commands before the Terraform init or after the apply. If you want to do that, if you have a way of querying the external tool and then bringing either a yes or no value back or something that you could process as a yes or no value, then you can absolutely utilize that in the tool chain. One question I get a lot is, do you support Sentinel? No, nobody supports Sentinel except for Terraform Cloud.
Right.
So there's so many people that are writing Sentinel policy, realizing that they can't take that anywhere else, and they're moving to OPA. If I can give any piece of advice in terms of policy as code today, even if you're using Terraform Cloud, start with OPA from the beginning, because if you do end up moving somewhere else, you find a different tool, you're not going to be able to take Sentinel with you.
Gotcha. Okay, cool. So let me, Ziggy, do you see has any questions popped up on the Twitter timeline, or has anybody hashtagged it?
Not that
I see that Jonathan Pierce is here. No worries. I am so glad you are here now. Thank you. Now that I am done.
Was he here to give you stress?
I don't know. He showed up at 8:17.
I see hearts from him.
Yes.
Oh,
thank you for coming.
Thank you. Come again. Brown bag. Double check. Awesome. Okay. Actually, Keith Townsend was in here a little while ago too.
Oh, awesome.
Had a couple of taco references to drop in the timeline.
Excellent. I love it.
Nice.
I always like these because then I get to go back and check Twitter later. Usually I'm on it actively, but when I'm presenting, I don't get a chance to do that. So when I'm on here, I get to go see what people were saying about me as I was doing it.
That's what our job is. That's what we're supposed to be doing.
Beautiful.
A quick question from Becky Elliott. Is there a vertical or a niche that is more suited for NV? Is it pronounced NV0, ENV0?
Yes, that is the number one piece of feedback I get is your name is hard to say. So it is M0, like environment zero.
M0.
It's kind of an homage to Auth0 for the name. There is no vertical. There is no niche. Anybody that utilizes infrastructure as code and could use some way to automate the deployment and add guardrails is for us. We support any vertical. We've got healthcare customers. We've got financial customers. We've got service providers. We are not in GovCloud right now, so I will put that asterisk on there. We do not have government certifications. We cannot handle government customers right now. We have our SOC 2 Type 2 report available, so anybody who is a little iffy about using a SaaS provider, we have that. We can absolutely provide that. We also have our self-hosted agent stack. So we do have a couple of banks that are utilizing us. So we do fit the compliance model. We can handle that, no problem. So whatever industry you are in, I am definitely open to hear it, especially if it's one that we don't have yet, because I love fitting us into different areas.
Okay. And since you did say managed service provider, do you guys provide a multi-tenancy model?
With the way that we have the organizations, the top level structure, you can spin up as many organizations as you want. Now, we do have one of our service providers that is asking for any of the constructs to span across organizations. As of right now, that's the top level construct. Everything within that is underneath it. Eventually, we may have it where different users can span across, or you may have different, templates that go across. But as of right now, no. But the service providers that we have are just utilizing different organizations inside for each one of their specific clients, which essentially creates tenancy inside the software.
Gotcha. So with the sub org, that becomes your quote unquote customer for that use for that.
Yeah. So they essentially have as the service provider, their credentials are authorized for like 15 or 20 different organizations inside of the product. Gotcha. And actually I can show you real quick. So let me jump back into here. I have the vBrownBag org that I created tonight, but I also have all of these different orgs like demo, M0 and all that. One thing that I like to point out, we actually utilize our own platform to deploy our own platform. So it's kind of like platformception. Exactly right. So we actually have our prod that I'm using right this moment is deployed using our application. So we absolutely invest in ourselves. We utilize it. So that's something that I think we're real proud of as well. But you can absolutely create as many orgs as you want here.
Oh, I saw the weekly cost thing. Do you guys monitor? Do you guys monitor the burn?
Yeah. Yeah. Hold on a second. Where is it? And 0. Yeah, let me show you that. So I talked about the tagging and how we have Terra tag. The way that we utilize that is we can actually come through, and since we're tagging the resources, and we just ask for read-only credentials into your billing API, and then we can come through. Let's take a look at this one here. Let's look at the deployment logs. So it's this tag resources phase that's actually going to go through, check all of your resources, tag the ones that are taggable. And that allows us to kind of create a cost over time correlated to deployments. So this is the cost over time for the last quarter, daily cost. Each one of these green lines is correlated to a deployment. For example, this one on the 21st made our cost jump from $1.11 to $2.23. So if we actually take and look at that, that was the 21st. We go to our deployment logs. We look for the 21st. We can come down to the Terraform plan. Search for the changes. We found the little tilde here. So there, we had an instance type change from T2 medium to T2 large, and that's what caused that spike in cost.
Very cool.
Now, as of right now, we don't have the ability to set budget limits like we do for policy. That will change very, very soon. That is on our product board. It is being worked on so that you can not only set the maximum number of environments or the maximum TTL for self-service environments, we'll also be able to set budget limits of this person can only spend $100 or what have you. You can do that today, but you have to kind of do it the hard way, or I guess the manual way with Open Policy Agent. Or you can, create a Python script that queries our API, gets the billing, and does some math. Everything you can utilize in our UI, you can do via the API. We have a CLI. So we fit into whatever kind of utilization model you want, whether you want to click around and do it, or if you just want to do everything from the API. And we also are halfway done creating our Terraform provider. So if you want to use Terraform to set up deploying your Terraform, you can absolutely do that soon.
And that will work in a master payer account model within AWS, where you're feeding all of your costing to one account for all of the sub accounts too, even though the tagging is account specific.
So the tagging is actually going to go through wherever the deployment is. But if you do have that master setup that can read through to your paying accounts, as long as we can go through and read through and find those tags and associate that with the bill, then yes, we can absolutely do that. You would just give us the cost credentials of wherever those deployments are going to be billed to.
Very cool.
Because you can the deployment credentials and the cost credentials are actually set up separately. So if you do have that master payer and you want to give the main account the credentials for cost or for costing, you can do that. And then we support not only key pairs and stuff like that for deployments. We also now support AWS assumed role for deployments.
I was just about to ask you that.
Cool. Yeah, we do AWS assumed role. We actually just launched that this week. But really, when it comes to deployments, we're deployed in AWS. Our self-hosted agent stack is an AWS stack. We can deploy to absolutely anything that there's a Terraform provider for or a TerraGrunt provider for. So anything they support, we'll support.
Nice. All right. I am dry on questions, and that's a good thing because we only have 4 minutes left anyway.
Yeah, well, we do have a burning question in the chat. Is how can we get some EM0 hoodies?
The good news is none exist that I'm explicitly aware of at this current point in time. But
and that was
since Jonathan is asking for swag, Jonathan can send me a DM on Twitter with his address, and I will have Julie from STK Promotions ship him a igloo bag with our logo printed on it. Hopefully you will retract your boo because of that.
He said, boo this man. I would retract the offer. I don't know. He threw that out way too fast.
There you go. Good man. Good man.
Very cool. All right. Awesome. Well, we have dried up the questions, I believe. Ziggy, did you have any questions? Did you want to give Mr. Tim a stumper?
Well, I am in full learning mode myself at the moment too. But I was pleased how much of this I actually could keep up with too, since I also like have, as we were talking about before the call started, kind of like I'm diving into this world and kind of
Awesome.
crashing in and working backwards. So this is really cool.
Awesome. Very cool.
Excellent.
All right. Well, Mr. Davis, longtime friend of the show. Thank you so much for popping by. We enjoyed it as always.
Hey, thanks for having me again. I appreciate it.
Cool.
Looking forward to talking to you again soon with the other group.
Wink, wink. All right. So next week we will be continuing our IT career series. We've got some really cool stuff lined up with video game developers, a video game house, somebody that took their entire infrastructure and moved it from on-prem to the cloud in under 3 months. So
Nice.
we will talk with you all then. Everybody have a wonderful evening and goodbye.